One of the most likely places in the solar system that we'll reckon we'll find life beyond Earth is on some of the moons of Saturn. Now that comes as a little bit of a surprise to people because they're expecting me to say something like Mars, for example. Now, while we haven't found any evidence yet for life on Saturn's moons, the conditions there are very promising. And so I figured I'd make a video on how we know the conditions are so good and what those conditions are, but also what's the plan to actually try and prove if life does actually exist around Saturn. NASA's Cassini mission spent 13 years orbiting Saturn, and in that time took 635 gigabytes worth of data, which has led to over 4,000 scientific research studies. Now, this mission didn't just focus all its attention on Saturn though, as beautiful as it is, it also looked at Saturn's moons, and this is where our evidence for possible habitability comes from for Enceladus and Saturn's biggest moon, Titan. Let's start with Enceladus though. It's the 6th largest moon of Saturn, but it's only 500 kilometers across, so smaller than the UK. Now, back in 2005, Cassini did 3 very close passes of Enceladus and discovered something very surprising, that there was a plume of water vapor coming from Enceladus's south pole. It was Hansen and collaborators in 2006 that managed to estimate that these plumes were literally spewing out water at a rate of about 200 or so kilograms per second. Over 100 geysers have been identified coming from these huge cracks in the surface that the Cassini team have nicknamed tiger stripes. Now, a lot of this water vapor actually falls back to the surface of Enceladus as snow, essentially, and it explains why the surface of Enceladus is so bright white and reflective. It's literally covered in pristine, pure water ice. But the rest of this water vapor plume has actually gone into building one of Saturn's rings, the E-ring. Now, to have water vapor literally spewing out of the cracks in Enceladus' south pole like this, there must be a very significant source of water underneath this icy crust of Enceladus. Perhaps a liquid water ocean. Now, the surface of Enceladus is incredibly cold. It's estimated to be around about minus 198 Celsius. So the idea of liquid water at that temperature isn't exactly feasible. However, Enceladus, we think, is much hotter than that in its interior because it's giving out 16 gigawatts
1.21 gigawatts
of infrared radiation. So it's being heated somehow from the inside, and we think that's to do with the interaction with both Saturn and also one of Saturn's moons called Dione. For every single orbit that Dione makes, Enceladus makes 2 in that time. The gravitational forces generated by that kind of interaction we call a resonance, but also being tidally locked to Saturn as well, causes lots of sort of pulling on Enceladus, which could heat the interior, giving you a moon that's essentially maybe a rocky core surrounded by this liquid water ocean and then this pure ice crust. So water is the one ingredient that we know all life on Earth needs to survive. So it's great that we found it on Enceladus, but it's a bit of a leap from just having water there to having life. You also need all of the ingredients, the raw ingredients for life, things like amino acids and proteins and complex hydrocarbons, things containing carbon and nitrogen, the building blocks that make up the stuff that makes up you and me and plants and all the other life that we can see here on Earth. But Cassini also flew directly through these plumes as well, trying to work out what they were made of except for water vapor, and found that not only was the water salty, just like oceans here on Earth, but it also contained things like carbon dioxide and methane and ammonia and hydrocarbons and other organic molecules. And that really made people sit up and pay attention. Not only that, in another fly-through of the plumes in 2015, Cassini managed to also discover molecular hydrogen in these big water vapor plumes, so H2, 2 atoms of hydrogen bonded together. To get that, you need some form of chemistry to actually make those hydrogen atoms bond together. Perhaps some sort of chemistry that's going on in the ocean itself. With the chemistry, you need some sort of energy source. And so the best explanation we had for how that got there is that there are reactions occurring around hot hydrothermal vents on the ocean floor of Enceladus, just like we see here on Earth that I'm showing in these video clips here. And on Earth, next to these hydrothermal vents on the ocean floor, we find extremophiles, microbes that have adapted to this incredibly extreme environment where there's no light, but they can survive thanks to the heat being given off by these vents. So Enceladus really is ticking all the boxes when it comes down to the things that we think you need for life, right? So you've got water, you've got the raw ingredients, you've got an energy source as well, so it looks really promising. But life is a lot more complex than just, having all the ingredients mixed together and hoping for the best, right? So it's not a guarantee that there actually is life there. But finding something that actually even resembles like something that we would call a habitat down here on Earth, up on a moon around Saturn, is absolutely remarkable. But what about Titan? We think Saturn's largest moon has liquid flowing on its surface in the form of rivers and lakes. So ESA's Huygens probe actually descended through the atmosphere of Titan, and also we have observations from the Cassini mission as well of the surface that also shows this. It is the only place in the solar system that we know of besides Earth that has liquid flowing on its surface. Now, it's far too cold for liquid water. We think all the water on Titan is just in ice form, but it is the perfect conditions for liquid methane and ethane. So liquid methane rivers and liquid ethane lakes and vice versa. Now, its atmosphere is incredibly thick, and it was found to be around about 96% nitrogen, and the rest, a lot of complex molecules. Again, the raw ingredients that you would need for life. Now, we do think there might be a much smaller subsurface ocean on Titan, but there's none of that tidal heating. It's probably quite cold. As I said, all of the water is just solid ice. It's not liquid water. And we think if there is any energy source for life, it would probably be in the form of volcanic activity. So a very thick nitrogen-rich atmosphere with a lot of volcanoes going on and not a lot of water doesn't exactly sound like a very habitable place, especially compared to Enceladus that we were just talking about. And yet that incredibly thick atmosphere of Titan hosting all of those organic compounds could actually be the perfect little petri dish for life. In 2012, Hurst and collaborators did an experiment where they mixed together all the gases that you'd find in Titan's atmosphere together in a lab to essentially recreate the same conditions. Then what they did is that they shined sunlight on it, sort of trying to recreate the kind of chemistry that could be going on in Titan's atmosphere. And what they found was that you could actually recreate some of the chemical building blocks needed for DNA. And this was actually the very first experiment that had ever done this without the presence of water. So it was a really big deal in itself, but also a massive deal to show that maybe you could be creating the building blocks needed for DNA in Titan's atmosphere. This made people wonder whether there could actually be life on Titan, but perhaps not as we know it. So instead of being water-based life, it could perhaps be methane-based life. And we know that Titan has a load of methane on its surface, so that could definitely be possible. Now, this is all speculation. Obviously, we've never seen any life on Earth that isn't water-based, that doesn't use water as sort of the base for all of its cells and to power it and to keep it alive. But we can sort of, with our knowledge of chemistry, make a good estimate of what life like that would be like and how it would power itself. So, for example, we suspect such life would take in hydrogen instead of oxygen, react it with C2H2 rather than glucose to produce methane rather than CO2. It's actually much simpler chemistry than what we do. And so in 2005, astrobiologists McKay and Smith said that if this was the case and there was actually methane-based life forms on the surface of Titan, you'd actually be able to see a trace of that in the way hydrogen was mixed in the atmosphere. And you'd also see less C2H2 at the surface because all of that molecule would be trapped inside of this life that was existing on the surface. Now this is all hugely speculative, obviously, and seemed like a massive long shot, especially in 2005. However, then there was some results from the Cassini mission. In fact, 2 papers came out in 2010. The first one by Strobel, which showed that there was so much more hydrogen at the top of the atmosphere than the bottom that you actually got sort of a hydrogen wind or a hydrogen cycle set up. And it was a way higher amount than the sort of conservative estimate by McKay and Smith for the amount methane-based life would actually need. The second one was by Clark and collaborators, and they found absolutely no evidence for any C2H2 in the atmosphere, as was predicted by some of the models sort of simulating Titan's atmosphere, suggesting, well, maybe it could have been trapped in life forms instead. Now, as exciting as that was, especially because it matched the exact predictions those astrologists had made 5 years earlier, it's still not proof of life. You know, that hydrogen mixing and the lack of C2H2 could just be explained by, again, some unknown chemical process or some strange volcanic process that we don't know of instead, and probably they are more likely. But to prove which one it actually is and what's going on, we really need to send another probe back to Titan. Now, unfortunately, there's no currently funded mission to explore Enceladus, but the good news is there is a planned mission to Titan, which has actually secured funding, and it's NASA's Dragonfly mission, which is essentially to send a little helicopter drone craft to the surface of Titan to explore it and look for signs of life. This is just one of the many, many reasons why Ingenuity's flights on Mars as part of the Perseverance mission have been so exciting, because it proves, first of all, that a mission like this would be possible. It tests the limitations of what we can and can't do. It also paves the way for future missions like Dragonfly to Titan. So Dragonfly is due for launch in 2027, which would mean it would arrive on Titan in 2034, which, yeah, is a really long wait. Just a reminder that development of these missions takes time and that space is big, mind-bogglingly big, and so it takes craft a long time to get to places. But I think even with just the slimmest of smallest of barest of chances that we might find life beyond Earth, but not only that, life that might have a different chemistry to our own and all of the astrophysical and even philosophical ramifications of that discovery, I think waiting to 2034, that would definitely be worth the wait. Before we get to the bloopers, I just want to say a huge thank you to this week's video sponsor, Brilliant. Brilliant is a website and app that helps you to learn new concepts in science by doing. And in my experience, this is the best way that I learn new things, literally just by getting stuck into a problem. Brilliant has interactive courses that guide you through new concepts step by step. Brilliant has something for everyone, from science to maths to computer science, but I particularly like their astrophysics course with this whole section on worlds beyond Earth, including this module on the Goldilocks zone that teaches you about the conditions needed for life as we know it here on Earth and how to calculate what they would be on other worlds. So if that sounds like fun to you and you want to support me and my channel, then head to brilliant.org/Dr. Becky, that's DRBECKY, and sign up completely for free. Plus, the first 200 people that go to that link that is in the video description down below will get 20% off an annual premium subscription, which I think is incredible. So thank you so much to Brilliant for sponsoring this video. You know, all of you, go forth and learn something with Brilliant. But for now, roll those bloopers. I feel like in my head, I always say Titan the way that Tarzan in Disney's Tarzan says Clayton. I'm like, Titan. I don't know why. Oh, people are going to think I'm so weird. Then what they did was they shined UV light on it, sort of trying to simulate sunlight. Sunlit? Lit? I've no idea what I just said. In Titan's atmosphere, because sunlight's really the only energy source that we know of necessarily that Titan has. And by doing that, fly. That was no reaction. It landed on my face though, and I thought it was just hair. Oh, off. Ah, it's buzzing around my ear now. It's like a mosquito. It's such a midge. Whatever we have in the UK. Exciting as it was that it matched the predictions that those astrobiologists have made 5 years. Voice, hello, I need you Tell you what, the conditions in this room today are too hot for life. I'm boiling.